All right, this is a great question about the polarity of bonds. Now we'll get to Lewis structures in the future, so we're not quite there, but you're used to seeing structures of molecules. And so what this is showing is that we're representing this bond here, this OH bond. Now, is there polarity and is there a dipole, which means a partial charge? And so we see all the answers have it. So we got to figure out, well, the first thing we can do is look at, well, these ones don't make sense, right? You can't have two partial negatives or two partial positives when you're doing a dipole. That doesn't make sense. In chemistry, we deal with opposite charges. And so in this case, with this idea of electronegativity, which atom is going to pull the electron harder, right? So they're sharing, they're still going to share. It's not a transfer like ionic, but it's an unequal sharing. And so what we have to do is jump to the periodic table. And if we're here at the periodic table, we see that oxygen is right here, hydrogen's over here. This is the most electronegative, this fluorine, and so oxygen's pretty darn electronegative. Remember, electronegativity increases going that way. It's how bad does an atom want an electron? Fluorine wants it the most because it's one away from a filled octet, just like anything in this column here. But the reason fluorine wants it more is because it has less shells. And so those electrons are really close to the nucleus and they're highly attracted and they want to fill that octet. And so oxygen is going to be more electronegative in this case. So if we're back here and we draw it, we're going to say between this bond, right? If it's more electronegative, it pulls the electron a little closer and that gives it more of a negative charge, right? Electrons are negative. So it's not oxygen ion, right? This is covalent bonding where they're sharing, but it is a partial negative to a partial positive. If we look over at our answers, we're going to see that here. So let's give that a shot. There we go. So this idea of a dipole and polar bonds is, what is that difference? If it's less than 0.4, the difference, and we'll have to look at electronegative table, which is also on your reference sheet, then it's considered a non-polar bond. If it's between 0.4 and 2, then it is a polar bond. Above 2, and we're looking at ionic. But the best way to look at ionic is in a metal and a non-metal. Now when we're in non-metal and non-metal, how much is that difference is the key.